Wonderful. So thank you again, everyone. You should be able to see the slides. We have a little copyright statement, and I'll jump into it. So to give you some background on what I do, I work for Carnegie Mellon University, and I have two different types of roles. My primary role is as a staff person, so I do research on a variety of different topics, mostly around humans and machines and how they work together, particularly for artificial intelligence and machine learning, a little bit of autonomy and other emerging technologies, and primarily work with government agencies here in the US. And I'm also, although I'm not going to teach this fall, for the past 4 years, I've been adjunct instructor, so teaching classes like interaction design and human-centered design, prototyping, those types of courses. So just to give you an idea of what I do. And previous to all this, for almost 20 years, I was working in industry. So I worked for a variety of different companies, very large companies and smaller ones, doing user experience work, human-computer interaction work on websites and mobile phones, all kinds of different things. So lots of different experiences. And now my primary work is research to reduce risk and avoid waste. So the work is mostly on software and AI systems. So I'm looking at systems that might help people make a decision support, working on systems that help people by making a recommendation to them or making a guess as to what the next likely thing is for something, working with large language models, if you've heard of those, so like ChatGPT. And voice recognition systems, so things like your smart speakers that you might have seen, and speech to text and text to speech, so live captions, which we can do through Zoom, and those are fairly good, as you've probably seen. And there are lots of other types of systems as well. So the biggest thing of all, the biggest waste of all, is building something that no one wants. And my job is to help people make sure that they don't do that they're not wasting time, wasting energy, wasting resources by building something that they haven't found a need for. So instead of, we could do this, why would you do that? Who are you making the system for? Who's going to use it? What are they going to use it for? Particularly with artificial intelligence, and with any software, the purpose of making it is for someone to use it. So it may not be that they interact with the individual pieces of that system, but they definitely will interact with the system in some way. And so making sure that that's aligning with the people's needs, that those considerations are being taken into account, is extremely important for the success of the project. Now, the work I do tends to be early prototyping. So we don't necessarily see our products get out into people's hands to use, but the work that we do will influence how that work is done. So we still are very interested in making sure that we're making the right thing for the right people. And taking a step back from that, you may be aware that everything that you interact with that's not just nature is designed. The physical things that humans manufacture and make are designed. Someone is making choices. Sometimes they're not making great choices. And again, that's part of my job, is to reduce risk. So if you look at these two cans, one of them is fly and insect killer, and the other one is canola cooking spray. But they look very similar. And you can imagine if they're on the same shelf in your kitchen, if you grab the wrong one, that might be very bad. So this is a bad design someone made, or maybe they just didn't make any decisions, but at some point there were decisions that were made that resulted in this. And other decisions should have been made instead to reduce the risk of somebody poisoning their family when they meant to just make dinner. So another thing that I look at is the considerations of changes over time. So this pencil was given to children, and you can see that as it got sharpened, which would be the natural thing to do with a pencil, the message did not support the goal of the pencil. And so, really thinking about how is something going to be used, what is going to happen as time moves on, how is that relationship with the system or the messaging of the system, whatever it is, going to change in different circumstances, or just as it's used, how is it going to degrade gracefully, if you've heard that term. And there's a long tradition of this work with many different names. My master's degree is in human-computer interaction, but the field, I usually tell people I work in user experience. It used to be called usability professional was a title about 15 years ago, 10 years ago, that stopped being used. And then interaction designers, program designers, project designers, there's all kinds of different terms, but people have been doing this work for 40, 50 or more years in different under different names, under different umbrellas. But the idea is always thinking about how people think. So like cognitive psychology, combining that with aspects of design and computer science, and really bringing those all together so that we're making systems that work for people. And so this may look familiar to some of you if you've seen the book, The Design of Everyday Things. It's called The Masochist's Teapot. So if you can imagine trying to pour water while holding the handle, hot water, you would get burned. So not, again, a bad design, but it's very pretty, it's very attractive. And so really thinking about how things will be used in the real world and designing better experiences is a primary focus of my work. So how do we decide what to do? Part of this is just making informed design choices. So really understanding how somebody is going to interact with something. So what I look at is how would someone use the system? What would they do to get the results that they need? And there's some basic practices that you probably interact with on a daily basis. The things you use easily and don't think about are well designed. So a button that you push looks like a button to push. I went to an elevator stand in a building I'd never been inside the other day, and I thought I pushed a button, and then I tried again, and some guy came up to me and he's like, "Is the button pushed?" And I was like, I think so, but I couldn't tell, and he couldn't tell, and like those kinds of situations indicate bad design. Whereas the situations where you just walk up and you flip a switch, or you turn a knob, or you interact with something easily, that is good design. And that when it results in what you expect it to. And so that's a lot of what we're looking at, is what's called affordances. How can I provide an affordance to someone so that they know or have an indication of what, when they do something, what will happen? So if you have an old style toaster where you push it down and then it kind of clicks, you have like that indication that it's on, that the toast is in the container and is being toasted. But there are other systems that don't give you that feedback, and then you're left wondering, is it working? Is it not working? We want to avoid that kind of thing, especially in more critical situations or more stressful situations when people don't have the time or the energy or the ability to really check on things as much. So my work is really focused on that, those interesting and influential topics that are of interest to my customers. So I have to work with them. So they might come to me with an idea. Often they have a very broad idea that they want to solve, and I help them to narrow it down and explore the options for what they want to do. And then we plan a research project. And sometimes I have an idea and I can pitch that as well. And then I have to convince many people usually that idea is worth pursuing, and then get the time and money that I need to be able to do that work. And most of my projects are pretty long. They're usually 1 year or more in time. When I was in industry, usually they were 6 weeks, maybe a few months of time, and that's it. Because there were deadlines and things needed to be pushed a lot faster. But in academia, and because I'm working with the government as well, they're long projects, and we have a lot of time to take a look at things and really work through problems. And I work with software engineers, machine learning researchers, other types of scientists, and people within the university and customers as well. So lots of different people, lots of different backgrounds, and that makes it interesting and fun as well. So the first step for our work is to really explore the situation, try to find out who will use the system, what they would do, what their needs are, really understanding that specifically so that we build the right thing. So you can't design for everyone and make things perfect for everyone. You really want to focus on particular people using it in a particular way. That way you make something that at least works really well for one group, and then other people will probably gain a benefit from that as well. And so to do that, we conduct different types of research and observations and interviews to really understand their context, their environment, how they're going to use something, and then apply that information. And so through those observations, we're learning the real process. So what we often find is, for example, if I asked your teachers what your process is for preparing for a test, they would probably have a very specific idea of what everyone should be doing. But if I talk to each of you, you would probably have a very different way of describing the work that you do to prepare for a test. And so what we want to understand is that real process. We want to understand what these people are doing themselves, how they're making workarounds. So, are you making a sheet for yourself to remind yourself of particular topics, for example? Are you using some other shorter version of a book, maybe some notes from other resources? What is really happening there? Something else we look at is just the number and the type of interruption. So if you can imagine people who are working like in a hospital, there's a lot going on. There's lots of noises, machines, they're making noise. There are interruptions from other individuals who need their attention. If a nurse is trying to put in a lot of information into a form or a system, they need to be able to stop what they're doing and attend to this other situation and then come back to it. And those types of activities are important to understand and be aware of, so that you don't build a system where they have to do 55 different things before they can save or exit the system. We want to make sure in that case that they're able to pause that work, save their progress, and walk away and come back. Also thinking about remote considerations. What might change if people are remote as we are today versus in person? They're very different interactions, and we try to avoid the hybrid situation because those are the worst, where some people are in a room and some people are online, and that just is always painful. We also want to understand how different processes might fit together. So I do something, and then I have a colleague down the hall that might do something else. How does that work? What am I doing? And then what am I giving that person? And then what do they do with it? And am I doing something like in an Excel spreadsheet, and then I send them the Excel spreadsheet, and then they have to convert it into something else and then back into another format? Understanding that may help smooth out that process if everyone can work in a similar situation, or if that information that I create can be transformed a little bit more easily into the format that they need. And then understanding also what is lost between systems. So what is it that I received initially before I did whatever I did and gave it to my colleague? Maybe I left some things out in my analysis that would have been helpful to the other person, and it doesn't actually get to them, or because I print something out and I retype it. There are lots of different transactions that we do during the day where information that could be helpful to someone else isn't helpful to me, so I don't include it. And there may be ways to fix that as well. And then we're always looking for key opportunities, ways that we could actually make a huge difference for people and improve the situation that isn't always obvious to them. So an old saying back before there were cars were that, and this is questionable who said it and when they said it, but the idea was that people didn't want just a faster horse. They wanted something different. And if you asked people, they would have said, perhaps if they rode a horse regularly, that they want a faster horse. But really what people wanted was not to have to feed and manage a horse, but rather to have a way to get from point A to point B without having to deal with a horse and do it faster. And a car, for better or worse, was the thing that in the US anyway, became the primary source of transportation. So looking at not necessarily just what people say, but really what's behind what they're saying. And also what artifacts are around them and are they interacting with. So really understanding this is just a messy desk, but there might be some really important information there that isn't necessarily obvious. So by watching people work, we can find out, oh, they keep looking at this notebook, or they keep looking at a Post-it note, whatever it is, that might indicate that there's something important there. It's a cheat sheet, it's some other type of piece of information that's actually really important. And if it was integrated into the system, it would make their lives easier. And what we do is just observe people using the system. So, at various events, I just would go to events and watch someone while they're doing the work. I also became a coal miner briefly when I was working for a company that made tires for large machines such as this. All kinds of different types of ways to observe people and their work and learn about what they're doing and why they're doing it. And sometimes I need a lot of gear for that. So here, I've got an extra phone and recording device, audio and video, and it just depends what I'm doing. Sometimes I'm putting on a vest and attaching my my camera to it if I'm out and about and need to have my hands free to take notes and that sort of thing. So it depends on the situation, what I'm doing, and how I do that. And then I need to analyze that information. So map out the information, look for patterns, figure out what people are doing and why they do it. Really, my goal is to create helpful references. So I don't want to create a huge report that no one's ever going to read. Instead, I want to really make visual artifacts. They don't have to be beautiful, but ones that convey the information that is important to them so that they can then decide, if I make the system this way, it's going to negatively affect this particular need. And if I make it this way, it's going to perhaps negatively affect something, but not the important thing. And so making those decisions as trade-offs is a really important part of making good software and good systems in general. And then ideally, and my computer is pausing 1 second. Okay, there we go. Make sure it's working. Okay. Then we want to share what we learned. So we use poster boards or visual areas online, a wiki, whatever it is, to make sure that everybody has the information that they need and that we've worked on so that we can talk about it. Because most of this work really requires people to communicate about what they know, what they have questions about. And so that helps us all to make sure that we're making the same product, that we all have the same idea of what we're doing, why we're doing it, and that we work together to make it the best experience we can. And then we prototype. So we start to create early clickable prototypes. Maybe these are all, these are both examples of hand-drawn prototypes. So this one is was for a potential handheld software, piece of software, an app. It was just really trying to figure out what would people want to have on a handheld app to interact with a car or whatever it is, and figuring out what it is exactly what this is about. And then on the lower right, just some what we call wireframes, early designs of something, just trying to figure out, how do I solve this problem and what interactions will meet the end user's needs? Is there something that they can do that I can do to help support their needs and to make that system easy for them to use, relatively easy for them to use, and really support their needs. So all this is about early learning. We're trying to get as much information as we can about what they are doing and why. And so we take that prototype and get it into a clickable format. And then we watch them, observe them using the prototype. This is called usability testing. And the goal is really to learn about people's interactions with the system, not to test to see if they can be successful, but rather to see if the system that I've designed is helpful to them. Are they confused? Are they annoyed? Are they unable to complete the tasks? If so, I need to change something. I need to fix that design so that it's more successful. And we do iterations of this. So we'll test an idea, one of those early clickable prototypes, and then we'll analyze our findings, see what worked, what didn't work, what do we need to fix, and prioritize that, and then make those changes to the prototype, and then do it again. And we just keep going through the cycle until we've got a pretty good prototype before we've done coding. So this is all early before we've actually started to make the back end of a system. That way we don't have to worry about wasting additional time making more complex systems. So then we actually start making the system. So that early wireframey thing. We start to add color, add images, whatever it is, until we actually have a workable system. And so I work with visual designers. I myself do not have that skill set. So I work with other people who do, taking my wireframes or my research and interpreting it into something that's really helpful to people and potentially, looks like a coherent group of designs with the other products potentially that the organization has, that sort of thing. And that's where the visual designer can come in and really bring the work to life. So then ideally I get to publish something or do a presentation or something along those lines. And so there are various different pieces that I've done over the years. These are some examples. So one's a checklist and agreement, and I wrote a paper with that was published with the AAAI, which is an AI conference. The middle one is a publication that I did with a customer of ours, where we really were looking at making responsible AI. So how to make systems that people are willing to trust, that are reasonable to use and do what they expect it to do. And then on the far right is another publication that we did here at the Software Engineering Institute on human-centered AI. So all kinds of different publications. I know some of you are doing research and are interested in academic research. So these are some of the publications I do. They are not necessarily similar to other academic works, but they are academic in the sense that they're early and these aren't production type pieces, rather they're references and resources for people. And when I'm publishing, one of the things interestingly in academia is, I'm sure you've heard the publish or perish type idea. Depending on the role you have, you need to be creating a lot of content. My role, I'm not required to do that, but I do enjoy doing writing and presentations and those types of things. So it's interesting to be aware of the different ways those are measured. And I thought this would be potentially interesting to some of you. There's this thing called an H index. And all it is, if you look on the right, an H index is looking at the number of articles someone has written or had published, and then looking at how many citations each of those articles have. And weirdly, what they want to do is look at the article that has the highest article published, so 6 in this case, that is equal to or greater than the number of citations. So it's a very strange measure, but this is the measure that's used to rank people who are doing academic work. I don't know if I explained that very well, but for me, on 3 different sites, I have 3 different H indexes. I just looked this up last night to see what the numbers were for this presentation. And so on Google, I have an H index of 4. So that means I have 4 articles that have 4 or more citations. Whereas on Semantic Scholar, which is a much more highly respected resource to look at authors and research, my H index is 3. So 3 publications. There I only have 5 publications though, but 3 of those have 3 or more citations, which is pretty cool. If you look over here, this site says I have 64 publications, or citations, I'm sorry. And the publications are, I guess they don't list that, they just list citations. So citations here are 64 versus 105 citations. So really very different, very widely different. And then for ResearchGate, which is another one, this is more of what they call a social media site. Here I only have an H index of 2, so 2 publications with 2 or more citations. So very different ways of measuring supposedly the same thing, but they all have access to different information, and they all have different requirements for what is appropriate to include and what is not. So it's something to pay attention to if you are interested in getting into academia. And a lot of these, it was interesting when I was looking for this description I found at University of Waterloo. they actually referred to some indexes or some of these types of organizations that don't even exist anymore. So things are constantly changing, even in academia, and it's just an interesting space. I'm going to pause there. Does anyone have any questions? Nope, you can unmute or put in chat. If not, I'll keep going. Oh, I see a chat. Okay. Yep. All right. I'm going to change gears a little bit then and talk about more about the work I do. So again, I'm trying to make responsible artificial intelligence, trustworthy artificial intelligence. The goal is really to help people to have systems that they are willing to work with. And if you are familiar with AI systems, they really are just systems that can recognize patterns, they can create predictions, they can make decisions, and in many cases, they generate new content. And this is all without being explicitly programmed to do so. So they are combinations of a variety of different technologies to make this happen. And artificial intelligence is a broad term generally that talks about a lot of different types of other technologies. And there's a lot of discussion in the field about whether that's the right term or not. Machine learning is another term, and that typically encompasses most of what people talk about when they talk about artificial intelligence. So machine learning includes unsupervised learning and supervised learning and reinforcement learning. So unsupervised learning is really putting a set of algorithms against some data and seeing what patterns it finds. It's a very rough description. Supervised learning is telling the system a little bit about the information and then having it use that knowledge to look for patterns. And then reinforcement learning is helping the system by telling it when it has done something correctly. So you're reinforcing it, much like you train a dog. You're saying, yes, you know, good job, good job, good job. And it will continue to use that knowledge to influence its predictions or whatever it is. Oh, I got a question. So the question is, what is the future of AI that you see, or what are researchers going to be focused on in the coming years using AI and ML advancements besides already existing systems like ChatGPT? That's a great question. I don't know. I do think that the large language models like ChatGPT are probably not going to be as big of a focus in another year or two. We'll see. I'm often wrong, but I think that the limitations of those systems are pretty significant as far as being useful for really most work. I think they'll be very helpful for simple tasks, but really for more deep, more detailed work, I think they're going to be more difficult to use. Also because the amount of data required to really have those systems work, large language models, it's huge amounts of data, and most organizations just don't have that much data that is AI friendly. So I'm not sure about that. I do think that we will continue to see significant improvements in our ability to use these systems. We've already seen with speech recognition and speech to text and text to speech, et cetera. Those areas have been just dramatically improved in the past 5 or 10 years. I expect that will continue as well. And hopefully we'll see some new ones too. But like things like autonomy, self-driving, autonomous vehicles, it's going to be a while. There are a lot of big challenges with those kinds of technologies. So I don't anticipate we're going to see significant changes from that perspective for 5 to 10 years, maybe longer, depending. So it's more incremental improvements as we move through. But thank you for the question. And machine learning also includes things like deep learning, neural networks, and those large language models. Those are actually just machine learning. But different organizations talk about these things with different words, so it can be confusing. But in the end, AI systems and machine learning systems are really just a combination of data, whatever the data is that you are trying to understand, combining that with algorithms, so that's math, just combining that with that math and programming and tweaking, doing some adjusting of parameters to get what you want. And so a model is an algorithm plus data and the programming to make it into a system that people can actually interact with. These systems know only what they're taught or have access to, and they control only what they're given control of. So they're aware, can be aware of nuances and can continue to learn, but only what they are provided access to or what they're given to learn. They're not able to draw on anything outside of that set of information. So if you see, like with ChatGPT, when it says something surprising, it's in the data set somewhere. Somewhere it has seen that pattern before, and it is just taking the next most likely words and putting them there. They may not be what you expect, but they are statistically what that system expects to be the next word. And so those systems in particular, the large language models do excellent grammar. So it will be a perfect sentence and it may make no sense whatsoever and be completely fabricated. But it will be statistically the most likely next words. It's autocomplete and it just continues auto-completing at a much faster and rate than your typical Word document or something like that. So these systems are really just taxonomies and ontologies coming to life. This is not how humans learn. These are not at all like a baby who can experience the world, who can touch things, smell things, taste things, and put together models of how the world works. AI does not do that. They are purely looking at the patterns in the data and making predictions or recommendations or decisions based on those previous patterns. And so if those previous patterns are all negative or have significant issues with them, the system doesn't know and doesn't care. It's not making qualitative judgments. It doesn't understand the actual words. It is purely doing pattern matching, unlike a human who can actually understand things in a real way. So they're not sentient, but that also means they're not unknowable. It's a computer system. It's something that we can understand. It does take a lot of time and is sometimes more time than anyone would like to take, but it is knowable in a real way, unlike a human who, we hardly know why we do things sometimes. So they're an example of how these systems can be helpful is if you think about physicians. This is an old statistic. So in a publication back in, trying to find the date, 2004, it was determined the physician would need about 90 hours of reading a week to keep up with research. So that was almost 20 years ago. And if you think about how many publications were done just on COVID over the past couple of years, that number is much higher at this point. So a physician can't possibly keep up with all the research that is occurring on a regular basis. But an AI system that is trained on a particular type of disease or a particular type of situation could help to bring the right information to the physician. It could enable the physician to make more evidence-based decisions because it's helping to parse out what the important information is. It's not to say it won't make mistakes, but at the same time, it could help the physician to at least access more information more quickly. May or may not be the right information, but better than no information in some cases. But making these systems do that requires a huge amount of information to be put into the system. So without data, there is no AI. And that is a significant issue for many organizations because they just don't have data that is, again, machine friendly, that is able to be integrated into a system. So it's a huge challenge for a lot of organizations to even begin to create these systems because they just don't have the data. So this is a quick, easy poll, and you may participate with your emoticons if you would like, or you can turn on your camera, raise your hand, whatever you'd like. But how many of you think that a tomato is a fruit? Okay, at least one person, two people, three people. Okay, three people say it's fruit. How many of you think it is a vegetable? Okay, all right, and we've got some people who aren't participating, which is fine as well. So it depends, right? So if I am making a system for a scientist, I would definitely make sure that tomato is always labeled or identified as a fruit. If I was making a system for a grocery store in the US, the tomatoes are often beside the carrots and potatoes and things that are more generally thought of as vegetables. And so at least in the US, when we go shopping for a tomato, we go to the vegetable section. And so if I'm making an application or a piece of software for a grocery store, I would call a tomato a vegetable, which doesn't necessarily make sense. But when you think about this pretty simple situation, and then you start to think about more complex situations, making the AI system understand human concepts is very difficult because the context matters a great deal. And so making just a tomato difference or a difference in terminology or acronyms, there are all kinds of situations we are able to, oh, you're talking about this because I'm in a grocery store. You're talking about a tomato as a vegetable, of course. But if I go to my biology class and for whatever reason we're saying tomatoes, I know it's a fruit. And we're able to adjust to those settings, and a computer can't, not without specific guidance. So it's really important that we communicate to the system and do what's called labeling of the data when there are specific meanings of things that we need to convey to the system. Another example of computer vision working here is thinking about a training set. A system is trained to recognize red, yellow, and white vehicles. And the data that encounters, if they're red, yellow, and white, we might say that that system's really a very good performing system. It's performing well. It's very effective in what it is doing. However, if we instead encounter blue vehicles, the system may or may not recognize them. And if it does, we need to think about what that is like. What does the person who is perhaps in the vehicle, what information do they receive? What if the system is encountering snow? All these images are on sunny days. What if it's snowing or raining? And what if the people in the car change? So what if it's your family in that vehicle? Does how that system reacts to things it doesn't recognize change? Do you want it to give you a false positive? Do you want it to say it's a car if it's not sure? Do you want to know how confident the system is in what it's telling you? And so these are all things to think about, and why semi-autonomous, autonomous vehicles are not are taking much longer than we expected, because these are really hard situations to determine what the right answer is. There isn't necessarily a right answer. It depends. And that's always a difficult thing for a computer to manage. We manage it quite well. So this is a wonderful quote by Dr. Joy Buolamwini. She leads the Algorithmic Justice League, and talks about how data is a function of our history. The past dwells within, showing us all the inequalities that have always been there. And so all data is biased because it shows historical information, it shows what has happened, and it's collected or organized for a reason. So someone decided they wanted to know more about this particular topic, and so they started collecting information about it. And they decided they didn't care about this particular piece of information, so they didn't gather that piece of information, and that creates bias. Those choices that people make as they're putting together information, making some information higher priorities, or making a preference choice, those all are biased decisions based on their goals. They aren't necessarily harmful, but they can be, and that's the important thing to look at. So that data is all biased. It's not inherently neutral at all. And again, it does reflect the priorities and preferences and prejudices of people making them. And this is from one of Dr. Buolamwini's early projects, where she was looking at camera and face recognition. She was using cameras for facial recognition, and the system could not see her. It would not recognize her because she has dark skin, and these systems were primarily trained with paler paler skinned men. And so her facial structure and skin color was not recognized by the system. So you can see the on the right, the ratings, they just didn't recognize her at all. And when she put on a white mask, it recognized a face, which tells you a lot about these systems. So realizing that the choices that are being made are going to affect what the system is capable of, and how the system is used could actually create harmful situations for people who are trying to use it, or who have to use it to interact with on a regular basis. And another individual who talks about this a lot is Sophia Noble. She wrote Algorithms of Oppression, How Search Engines Reinforce Racism, and she did just some searches. She just used Google search and searched on why are Black women so, and then watched for that autocomplete. And it was extremely negatively biased. It was racist in the way it was presenting that information about those individuals. And so she wrote this book really talking about how the search engines can reinforce racism, because if that next word that you get is indicating a negative bias, that can also affect your thoughts and your knowledge about things. And so really interesting and good work that she's doing as well. So we want to make responsible and intelligent decisions about design, and be intentional about this work, and keep in mind that just because we can doesn't mean we should, and that there are implications that we need to think about how these systems can affect real people and potentially really be bad for individuals or groups of individuals. And part of this is just having this conversations I already talked about. Really conversations for understanding, talking about what we value, who could be hurt, and thinking about what lines we don't want to cross. Where are we going to say, we're not going to do that? And how are we shifting power? So who is gaining information, knowledge, money, access, all those types of things? It's important to really think through the implications of the work we're doing. So I'm going to pause there, because I have more content, but I also know that we want to make sure we have a good conversation here today.